Hello and welcome to the course on C programming language. This is the fifth lecture of Unit 1, and in this lecture we will continue our discussion on number system. This is the part 2 of our discussion. So let's begin. If you remember, in the last lecture we are talking about number system, and there I have explained about decimal number system that we are using in our day-to-day life. In this lecture, the other three number systems which are coming under the positional number system will be discussed. So let us start with binary number system. Here you can identify that in case of a decimal number system, we are using 0 through 9. These are the digits we are using while we are considering the decimal number system. If you remember, this is in decimal number system we use 0, 1, 2 up to 9. These digits are used to form a number. But when a binary number system is concerned, then you have to use two numbers. Decimal stands for 10, so you use 10 numbers. But in case of a binary number system, as bi means 2, so you will use two digits to create a number. So what are the two digits? 0 and 1. Generally, computer understands binary number system. Computer do not understand the decimal number system. So every number which we want to provide it to computer, it needs to be converted into binary numbers so that that computer can understand those numbers. Okay, so you can take an example. So this is an example of a binary number system, that is 110101. Okay, and whenever you are writing any number system, you need to specify the base of that number system, where in this particular case the base is 2, because in binary number system we are using two digits, so the base is 2. In case of a decimal number system, let's say 654, so this is a decimal number system and the base is 10. Similarly, for a binary number system, the base is 2. Now interestingly, as the computer uses binary number system, so we can say that whenever 8 digits combined together, when 8 digits combined together, sorry, let me click on this. When 8 digits combined together, we call it as a byte, right? So for an example, each digit of a number system, here let's say this is 110, then 101. These are the digits, okay, 11. So these are actually called bit of that number system. When such bits are combined, and 8 bit forms a byte. Okay, and you know that every binary number has some positions. Means every positional number system has some position. So this binary number has also having some positions, like this is the 0th position, this is 1st position, this is 2nd, this is 3rd, 4th, 5th. Okay, the interesting fact over here is, if you remember, in decimal number system I have already told you, when each digit of a number will multiplied with the base to the power its position and all the value gets added, it gives the decimal equivalent of that number, right? So let us take with this an example. Okay, so you can see here, this example I am just trying to execute what I have already told you. You can see these are the positions as per the discussion previously. This is which position? This is 0th position, this is your 1st position, this is 2, this is 3, this is 4, and this is 5th position. Now if you want to multiply 1 into 2 to the power 5, where 2 is what? 2 is the base of that digit. Okay, 2 to the power 5 plus 1 into 2 to the power 4 plus 0 into 2 to the power 3 then 1 into 2 to the power 2, then 0 into 2 to the power 1 plus 1 into 2 to the power 0. Okay, so if you consider this operation, and where 2 represents the digits position, 1 represents the digit positions, obviously 3, 4 all are digit positions, and this 2 represent the base. When you calculate this, you will get 53. So what this 53 is actually? It is actually the decimal equivalent of this binary number. So this is 53 is actually the decimal equivalent. Okay, so that means if a number is given in any number system, let's say in binary number system, or it may be octal, or it may be hexadecimal number system, when you multiply the each digit with its base to the power position, then you add all of them, you will get a number which is actually the equivalent of, means that it is equal decimal equivalent of that particular number. You will be soon clear when we will discuss all the number systems continuously. That means indirectly we can say, whenever it is indirectly we can say that if you will be asked a binary to decimal conversion, if somebody will ask you how to convert a binary number to decimal number system, this is the procedure you have to follow. So this is actually showing the procedure how to convert a binary number system to a decimal number system. Okay, that's all for this slide. Now let's move to the next slide, that is your octal number system. As already been told to you that a octal number system is again using the 8 digits. Okay, so what are the digits? 0, 1, 2, 3 up to 7. Like in a decimal number system you use 10 digits, in octal number system you use 8 digits. So what is an example? The example is 435 is an example of an octal number system. So here the base is 8, right? If the similar rule will be followed, as like previously I have already explained, if the similar rule will be followed, you can see here, if you multiply each digit with its base to the power the position, let's say this is your position 0, this position is 1, and this position is 2. Now if you multiply these things, what you will get? 4 into 8 to the power 2, 3 into 8 to the power 1, 5 into 8 to the power 0. Same thing I have written here. 0 represents the digit position, 1 represents the digit position, 2 represents the digit position. Similarly 8 represents the base of this number, because we are using octal number system. What value you will get? You get 285. Actually this 285 is the decimal equivalent of this number 435. Okay, so indirectly if somebody will ask you what do you mean how to convert a given octal number to its decimal equivalent, then you can easily say that we should follow this formula to find out the given octal number to its corresponding decimal. So this figure indicates that octal to decimal conversion, how to do that, and this is the procedure how to convert a octal number to its equivalent decimal number system. Now let us go to the hexadecimal number system. Similarly, as like your octal number system, in decimal number system you use 10 digits. In octal number in decimal number system you use 10 digits. In octal number system you use 8 digits. Similarly, in hexadecimal number, hexa means 16, so you use 16 digits. So what are the digits? 0 through 9, 0, 1, 2, 3, 4 up to 9, and then 10. These numbers, that is A, B, C, D, E, F, is actually representing 10, 11, 12, 13, 14 and 15. So starting from 0 to 15, there are 16 digits we are using. But remember, while I am writing an example of this, let us take an example of hexadecimal number system. This will be looking like this, like 24B4. So that means 2, 4, these digits we are using. So B stands for, B is equivalent to 11 actually. But while we are writing hexadecimal number, we should follow this notation. 24B4 of 16 is our hexadecimal number system given to you. Okay. The similar rule, let us take the similar rule as we have already followed. If you follow the similar rule, that means if we try to multiply the base to the power digit into the base to the power the position, then whatever we will get, that will be the decimal equivalent of this particular digit. Okay, so let me clearly mention you. So this is your zeroth position, this is 1, this is 2, and this is your third position. So you have to multiply 2 into 16 to the power 3. 16 is the base and 3 is your position. Similarly 4 into 16 to the power 2. Similarly b into 16 to the power 1, then 4 into 16 to the power 0. So when you perform this operation, so that will be you will get 9396. So 9396 is nothing but this is the decimal equivalent of 24b4 of 16. Okay, so indirectly if somebody will ask you, if a hexadecimal number system is given or hexadecimal number is given, how to convert it into decimal? So this is the procedure you have to follow to convert it into decimal. Okay, I hope you understand all the four number system that we have discussed right now. So what we have discussed, where we are actually. So let us go for the next slide. So where we are now. So we have discussed four different number systems. So what are the number system? One is called decimal, second one is called binary, third one is octal, and fourth one is hexadecimal. So quickly recap the things. In decimal number system, how many digits you are using? 10 digits. In binary number system, bi means 2, so 2 digits. In octal number system, how many digits you are using? 8. And in hexadecimal number system, how many digits you are using? 16. But while you are using 16 digits, in this particular case, what will happen? You will use 0 through 9, it is okay, but 10 you should not use. Instead of 10, you are using A, B, C, D, E, and F, that is 10, 11, 12, 13, 14, 15. Okay, this is the hexadecimal number system. Okay, so by using these digits you write your hexadecimal numbers. Now the interesting fact what we have learned here is, the interesting fact over here is like this. Suppose a number is given with some digits. So this is a number actually, a through n is a number. There may be several other digits present. So a represents a digit, b represents a digit, c represents a digit, and n also represents a digit. Let this number is having a base z. So I am not talking about any particular base system over here. So z indicates any number system. So any number given to you with any base, then if you and let's this represent the digit positions like 0, 1, 2, and theta. So theta represents the last digits position. I'm just using a symbol that it obviously be a number. So the positions will start from 0, 1, 2, 3, 4 up to theta. Okay, so last digit I have given the number theta. Okay, now this is if this type of number system is given and you perform this operation. What is the operation? You will perform the digit into the base to the power the position. So here you can see the digit is n, base is z, z to the power theta, plus dot 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 dot. This is the another digit. So c into z is the base to the power the position 2. Similarly b into z to the power 1, b into z to the power 1, a into z to the power 0. When you perform this operation, you will get another number. It may be like this. Let's say ABC up to n, some number you will get, and obviously this base will automatically change to decimal. That means in any number system, if you get a digit, using any number system, if a number given to you, then if you perform this operation, whatever you get, it is the decimal equivalent of that number. We have already discussed in the previous slides. Right now, the question is only these four number systems are possible? Means that there are only four number systems, that is decimal, binary, octal, or hexadecimal. Is there any other number system is possible? Yes, we can create other number systems too. That means let's say I will create a number system like a penta number system. Okay, penta number system. So I will try to try to tell you that this penta number system uses 5 numbers, that may be 0, 1, 2, 3 and 4. So these 5 digits is used to create a penta number. So let us take an example. So example of penta number system may be 2, 1, 4 of 5 is actually a penta number system. So that means the base of this number system is 5, right? So if this is the number system given and somebody will ask you if a penta number system, by using a penta number system, a penta number is given, how to convert it into equivalent decimal. So what you will do, so this is your 0th position, this is 1th position and this is your 2nd position. So what you will do is 2 into base is 5, 5 to the power 2, okay, plus 1 into 5 to the power 1 plus 4 into 5 to the power 0. So what will happen? 25 into 2 is 50 plus 5 to the power 1 is 5 into 1 is 5 plus 5 to the power 0 is 1, 4 into 1 is 1. So what you will get? 50 plus 5 is 55 plus 1 56. So I can say that in decimal number system this 214 of base 5 is equivalent to 56 of base 10. Got it? So this is how other number systems are also possible. I may ask you that hexa number system. So hexa means penta, hexa. Hexa means your 6 maybe. That hexadecimal number system will not be hexa means you can create a number system like 25 of 6. So the base is 6 here. You may create numbers like for 45 of 7. So this is the base is 7. So there are enormous number of positional number system can be built up. Okay, so that's all for the today's class. Thanks for listening. Let me clear this and let me go to the thank you slide. Bye bye.